Hello friends, welcome to Head or Tail Education. Today our topic is electrons in orbit. Now, what is orbit and what is quantum numbers? So this is the moving path of electrons. Okay, so orbit is moving path of electrons, or there is area where higher possibility of electrons. Here two force works. First one is electrostatic force of attraction between electron and nucleus. So first force is this, and second one is centrifugal force, which direction is outer side. So this direction is outer side. So two force. Electron moving path is stable circular orbit. So this is the stable circular orbit. While moving, no energy loss. While moving, no energy loss due to electromagnetic rays. Due to electromagnetic rays. Okay. Quantum numbers. To know the position of electron, configuration of electron, and energy of electron in atoms, we use four specific number. Okay, is called quantum numbers. So quantum numbers are four type. So first one is principal quantum number, shows by n. Second one is azimuthal quantum numbers, shows by L. And third is magnetic quantum number, shows by M. And fourth is spin quantum numbers, shows by S. So first quantum number is principal quantum number n. This quantum number represent of atom main energy level where electron is present. The value of n 1, 2, 3, 4, 5, etc. is whole numbers. These values are equal the shell K, L, M, N, O, etc. So here, so principal quantum number is used to main energy level of atom. So what is the energy of atom is decided by principal quantum number K, L, M, N, O. So this is the first K, then next L, then next M. The quantum numbers decides energy of main level, okay, and the average distance between electrons and nucleus. So quantum main principal quantum number is also decide the distance between electron and nucleus. Increase the value of n means increase the number of main level, then distance is increased by from nucleus. So this is correct. And also energy also increases. Okay, so this here K means first n equals to 1 means first very nearest to nucleus, electron is very nearest to nucleus, and increase energy is low here. Now second L equals to 2, so increase the distance from electron and nucleus, and energy very increases. Okay, now M equals to 3, now distance again increase from electron and nucleus, so again increase the energy of electrons. Second one is azimuthal quantum numbers, which is shown by L. So orbital angular moment of all electron in main shell are different. Also, very little difference in energy of electrons means different subshells are available in main shell. This quantum numbers decides number of subshell, subshell nature and energy of electron in subshell and orbital angular momentum from in main shell. So the total number of subshell is equal to number of main shell. So this quantum number, azimuthal quantum number, is used for decide the number of subshell, nature of shell nature and energy of electron in subshell. So the total number of subshell is equal to number of main shell. So the main shell number here, see, so k equals to 1. Okay, this is the main shell and n equals to 1. This is the number of main shell and the subshell value number of here is 1 subshell. Okay, now next if we check the number of main shell equal to 2. Okay, and we'll again the equal value is L. So L have 2 main shell. So here is S and P subshell. Okay, now this M, so M, the number of M value is N equal to 3. So here the subshell is S, P, D. Okay, now N, the value is 4. So subshell is S, P, D, F. So this is the subshell. The main shell is K, L, M, N. Okay, the proof is the very small difference are available in electrons inside the main shell. So we decided, so the main shell are also divided in few subcells. Okay, the shape of subcells is, so L equals to 0. This is the subcell, here S represent. Okay, so this the shape is sphere. Now L equals to 1, the subcell is P. So this shape is dumbbell. Okay, dumbbell like this. And L equals to 2, the subcell is D. So this is the double dumbbell like this and this. Okay, now L equals to 3, so subcell is F, and this time the structure is going to complex in F. Okay, now L equals to 4, so now S, P, D, F subcell is again next subcell and structure is very complex atom. Okay, this is the shape of SPDF orbit. So this is the S subcell. Now this is the P subcell. So P also have 3, Px, Py and Pz. And this is the D shape of subcell. Okay, so D, XY, then YZ, then XZ. So all we have double dumbbells here. Now dx square minus y square also, the dumbbell is 90 degree each differences. Now dz square, this shape of D subcell. Okay, so D have the 5 types of shapes here. Next quantum number is magnetic quantum numbers, which shows by M. So M is again very useful because the electrons have negative charge. Okay, so by this reason all around of nucleus due to orbital velocity, okay, generate magnetic field. Then magnetic field react with outer side magnetic field. After that its orbital angular moments effect. Okay, then Effects of electrons orbital momentum. The electron is destructed from original path, then adopt various orientation. So selection of these orientations by using magnetic quantum numbers. When the electron is moving the orbit, so due to the orbital angular momentum, the path is destructed. Very okay. So these magnetic numbers is used the orientation of. So each value of L means every value of L, the total value of magnetic quantum number is 2 is multiplied by L plus 1. So the possible value of is minus L, 0 and plus L. So these will number between range is this minus L to plus L. So total value of electron in any shell is equal to is multiply 2L plus 1. Okay. So in this table we have seen if L value is 0, so subcell is S. So magnetic quantum number here is 0. Okay. And here is magnetic, here is maximum electron is 2. Okay. Now next one is 1. L value is 1. So subcell is P. So here magnetic quantum number value is 3. So range is plus 0 and minus 1. So here maximum electron is 6. Next one is 2. The subcell is D. So D have 5 magnetic quantum numbers value. M equals to 5. So plus 2 plus 1 0 minus 1 minus 2. Maximum electron here 10. Next L equal to 3. Subcell is F. So M is value equal to 7. So plus 3 plus 2 plus 1 0 minus 1 minus 2 minus 3 and total number of electron equal to 14. So this is the magnetic quantum numbers. Now next is spin quantum numbers, which is shown by S. So what is spin? Because electron is moving around the orbit. Okay, so electron moves all around of nucleus and also moves on its own axis. Okay, so first is moving around the nucleus and again moves on axis. So this motion is called spin motion of electron. So by this motion very weak electromagnetic field generates by. Okay, now next the spin of electrons are two types of electrons spin. First one is anti-clockwise and second one is clockwise. The value of spin quantum number is plus half and minus half. Electron spin angular momentum is equals to by using the theory of quantum is equal to h by 2 pi is multiply then square root s is multiply s plus 1. So this is the theory of quantum according to now classical theory. So s is multiply h by 2 pi, so equals to s equals to half. Next we discuss Pauli's exclusion principle. So what is the Pauli's exclusion principle? So Pauli says maximum 2 electrons are filled in single atom orbit, but their spin should opposite. Okay, like this is the 1s orbit. Okay, so here we fill the electron maximum 2, but the pair is generated the opposite spin. So first is clockwise, then next is anti-clockwise, like the sets of all four quantum numbers, which is n, l, m and s. Okay, values are not same of single atom of any two electrons. So this is correct. See, in all levels of quantum numbers, so every electron's values are different. The value of n, l, m are same, but s are different. So n and m the same, but s are different. Okay, because the s is a spin quantum number here. So every electron is plus half and minus half, like this. Now next, the rule of Hund's rule of maximum multiplicity. So by using this rule, we fill the electrons. Okay. So what is saying? Says the rule: all electrons are filled one by one with equal spin in single subcell. Okay. Then start to fill the pair with opposite spin electron. Okay. So first we fill in each subcell, like first one electron, then second electron, the third electron, like this. Okay, so this subcell is S. So first fill 1, then next to fill again 1 electron, but spin is reverse. So it means the pair complete in every subcell, like S, the pair completes by second electron. Okay, first one is this, and again new electron pair is this. Now P subcell pair is complete after filling 3 electron, means first electron here, second electron here, third electron is here. Now next, by using the pair, fourth electron is going here. Okay, D subcell is filled by sixth electron pair. Okay, and F subcell by eighth electron, generating the pair, because the F after filling the 7 electron, so 8th electron is using for pair. Same like D subcell, fill the 5 electron, then 6th electron is using for pair. Now according to Hund rules, atoms with fill half filled, okay, like P3, D5, F7, and full filled like P6, D10 and F14. So these type of field is orbital is more stable. So now below example, we apply the Hund rule and Pauli's rule in by using the carbon example. Okay, so what is the uh, number of atomic number of carbon? Z equal to 6. So according to main level, the K, so first fill is by 2 electrons with opposite screen. This is okay. Now next, again fill, the level is L, and 2s is filled by opposite electron with opposite spin. Okay, 2 electrons. Now if again we fill the p orbit, okay, like this, with opposite spin and 2 electrons. Okay, so this is the wrong, because the rule is saying p3 is more stable. Okay, means we required here 3 electrons, but carbon number is 6, so we filled by different way, so this filling is wrong. Okay, now by applying the rule, so 2 is okay, 1s2 is okay, and 2s2 is okay. So by using 2, so for 2 electrons we will fill like this. The first electron is coming in this p, okay, in the x, and the second electron is again coming for y. So this pair or this filling is correct and more stable than before. Okay, so this is the carbon example. Now one more example we take for nitrogen. So what is the value of atomic number of Z? Nitrogen is equal to 7. So in the first example, if fill like this, 1s2 okay, 2s2 okay, and third like 2p2 okay, and because 6 and 1 electron is here, so this pair is also filling is also wrong because stability is not here, so this configuration is wrong. Now correct is k, the 1s2 is okay, now 2s2 is also okay. Now this is wrong here, so first fill 2p1 like this, then fill 2p1y y-axis, and finally fill last electron this type 2p1z. So this the configuration of is very stable as compared to this. Okay, now again we check, we have the principle. What is the principle is saying? This is Aufbau principle. So Aufbau principle is saying, so according to Aufbau principle, first electron is going 1s okay, so this is going here 1s, so we filled 1s, no issue. Okay, now the according to direction, the dash dash is coming here, and second is filled in 2s orbit. Okay, so again we fill the 2s orbit, this is okay. Now third one is going after 2s, this coming 2p, this is also okay, so 2p is fill up. Then we come 3s, so 3s is okay, then we according to direction fill electron in 3p, then becomes 4s, then again according to direction we come here d. Okay, next fill for p of course, then next fill 5, so filling like this. Okay, so if for example we have the chromium. Okay, so chromium, the number is atomic number is 24, so first fill is 1s2, so these two electrons are filled. Okay, next fill is here 2s2, so 2s2 also again okay. Third one is fill is here 2p6, this configuration is okay here 2p6. Okay, and next is 3s2, so 3s2 is okay here according to direction. Now next is 3p6, so is going here 3p6 is also okay. Okay, now next 3d4 and 4s2, so here, so 3d4, so 3d4, so d the value of electron is 5. Okay, and so 4s2 is electron is 2, so but this is not stable. The reason is because the d pair is incomplete, so correct is like this 3d5, because we here we are using the rule of Pauli's rules and Hund's rule. So 3d if 5. Okay, so first fill the 5 electron in 3d orbit, then 1 electron in 4s orbit, so this configuration is very stable. Okay, so this is the right electronic configuration of chromium. Now tell summary. We learned orbit and quantum numbers. Next learned how many types of quantum numbers. So 4 types of quantum numbers. First one is principal, then azimuthal, third is magnetic, and fourth is spin. Next, discuss the shape of s orbit, p orbit, d orbit, and f orbit. Then we learned Pauli's exclusion principle and Hund's rule of maximum multiplicity of electrons. Okay, then example, and finally discussed Aufbau principle for electronic configuration. Hope tutorial will help to understand the electrons and electrons in orbits and how to fill the electron in orbit. Okay, so thanks to watch Head or Tail Education.